this is not exactly true, because you remember that we're going to have another last session, Q&A session, on the 26th of May. So you remember this? Don't forget the Q&A session on the 6th May. Okay. So today I want to talk about something which is important, and which is about risk management for banks, and more precisely, why did the risk management function was not able to was just horrible and a disaster during the last subprime mortgage crisis. That is what we are going to look at today. Okay. So usual questions before going into the details. Do you see me and do you hear me clearly? Okay. Okay, great. So we can start. Okay, great. Thank you. Great. Yes, that is what I am interested in. Okay, so we can start now. So the question is, financial risk management. When does independence fail? And actually, when does it go to a disaster? So by the way, what we're going to do is based on this article written by David Sraers, David Tesmar, and Augustin Landier. And there is also one thing which is important: the report sent by UBS to all its shareholders. Why? Because we saw yesterday, so maybe you remember this, and this is one way to make the introduction. Yes, let me. So you remember this exercise we went through yesterday. But at the end of this exercise, there is something about. Yes, there is something about depreciations. Depreciations due to subprime crisis. And if you look at depreciations, the first one is UBS, Union des Banques Suisses. World record depreciations amount for UBS. And actually, in the report, they absent to shareholders. They explain UBS in this report. UBS explains that the huge depreciations are due to malfunctioning to misfunctioning of the risk management function, of the financial risk management system. Okay, and by the way, after this, UBS totally modified the way that its risk management system is organized. Okay. Okay, so normally the idea of risk management division is to be a counter power to the executive function, and in particular to those who are in charge of taking risk for a bank, I mean traders. Okay, so normally, let's say, there is a notion of counter power. There is a notion of counter power of the risk management division. So the great advantage of central risk management, independent of business unit, is the absence of conflict of interest. So in other words, the central risk management is not driven by the market. So maybe a few words about that, just to be sure that it is clear. So before this crisis, actually, there was two ways to make risk management. So first way, okay. So before the prime mortgage crisis, there were two ways of doing risk management. For a bank. So the first way was to put risk management division at each business unit. Donc, business unit 1, risk management. Business unit 2, risk management. And so on and so forth. Business unit N, risk management. So risk management N 2 1. So in this first version, risk management is not independent. Well, is included in each business unit. So in other words, risk management is not independent. Is not independent from business. So, in other words, risk managers do not report to the bank, to the board of the bank. So let's say to the bank CEO, but to the director, let's say, of each unit, each business unit. So of course, and the director of each business unit is going to have a huge bonus if result of his or her business unit is high. So time to time, that guy is not going to listen risk management advice. Okay, because that guy is also business oriented. So that guy is business oriented, and time to time he or she is not going to listen to the risk manager, to the risk manager of his her unit. Okay, so this was the first way. The second way is to put only central risk management. So independent from business units. Okay, so there is a clear distinction, a wall, let's say a wall, between risk management and the business units. Business unit 1, business unit 2, business unit N. So there is a clear distinction, clear separation, clear separation between the two. Okay, so in other words, the chief risk manager, in that case, the chief risk manager reports directly to the board and not to the business units. So in this second way, second option, Risk management. In that case, risk management is independent. Well, more independent from business consideration. Is more independent from business consideration. Okay, so do you hear me? Yes? Before the prime mortgage crisis, two possibilities were, well, the were in place. Some banks used rather the first way and others the second way. Okay, but actually, there is something which is clear. There is a clear lesson from history that all the banks which were using first way, almost all of them went to bankruptcy. So now there is only one way to make risk management banks correspond to the second way. The first way no longer exists. Okay, because it was just inefficient. Okay, and for instance, UBS, which is still alive, used the first way of doing risk management. Okay, but they really lost a lot of money. They always went to bankruptcy. Almost, not always, but they almost went to bankruptcy. UBS almost went to bankruptcy. Okay, is that clear? The two ways. Is that clear for you? Two ways of doing risk management. Let me know if it is clear for you. Okay, thank you. Okay, so now I'm going to come back to my slides about financial risk management. Okay. So what you have to understand is that here, what we are going to look at is the second case. So this is, here we are talking about the second way of doing risk management. And what we are going to see is that even with this second way, there are potentially problems about this notion of counterpower. So the problem is that even with this more efficient way of doing risk management, time to time it doesn't work. Okay. Okay, so it seems not to have worked correctly. So for instance, UBS has identified risk management malfunctions as one important source for its multi-billion-dollar subprime-related loss. But remember, this bank was not using the second way, but anyway. UBS analysis identify a number of factors within the risk control functions, especially within market risks, that suggest that the overall risk control framework was insufficiently robust. So just a few words about that, because I think it is very important to understand. So in 2008, UBS was really close to bankruptcy. And you know, in terms of trust, shareholders actually have lost their trust on UBS. And everybody was just thinking about selling shares and investing somewhere else. So UBS was forced to write a very serious report to all its shareholders. So the report was quite huge report. And moreover, UBS modified deeply the way, in particular, risk management was organized in order not to do the same for the bank, not to do the same mistakes again in the future. So this is really crucial, and I think this is maybe the only example I know about a bank doing something like that. Okay. So normally, the role of trader T, let's say we're gonna call it capital T, is to select an asset to invest in, while the risk manager, RM, can decide to approve or not. Due to his compensation structure and limited liability, T, the trader, has an intrinsic preference for the riskiest asset, even though such a selection can be value destroying. And this context, giving a different compensation structure for RM may elicit an optimal behavior from the trader. Because he knows that RM has no particular interest in letting the risky asset go through, the trader will more often feel compelled to make the efficient choice. So by the way, I've got one question for you. So tell me, why is a trader why does the trader why is the trader willing to take excessive risk? Why is it the case? This is partly true, but not only. High risk, high return. So this is true in the sense that high risk high return when things go in the good direction due to bonuses. So this is part of the answer. So in other words, due to bonuses, trader benefits from the upside risk. Yes, you're right. It's not the compensations are not based on the risk management activity. That's right. Only about returns. But moreover, due to limited liability, once again, traders are protected from the downside risk. They are protected from the downside risk. Okay, so they benefit, traders benefit from the upside risk, bonuses, but they don't. And they are protected from downside risk. Okay. So this is why naturally they want to take excessive risk. And normally the role of the risk manager is to be the counter power and to avoid traders taking too much risk. Okay, so this is the second part. What is written over there? Okay, so the question is, why didn't it work well? So here is the model that we are going to consider. So there are two agents, trader T and risk manager RM. There are two states of nature, S1, S2, which potentially can be realized with same probability, 0.5, 0.5. There are two assets, asset 1 and asset 2. And the risk manager, so first the trader takes the decision whether to invest in asset 1 or in asset 2. And then the risk manager can either confirm choice of the trader or reject this choice. So you see that if the trader anticipates that the risk manager is going to reject a choice, well then is going to be he's not going to choose that investment, okay? Because if he knows for sure that the risk manager is going to reject it, well, there is no it's not interesting to choose to select such an investment. So the risk manager, let's say, takes its decision based on its information about the cost of capital, C, but the cost of capital is randomly distributed. So this is random variable. Okay. And this is the distribution function of this random variable. So in other words, the cost of capital can be either high or low. Okay. And of course, this is going to impact on the viability of the investment. Okay. So depending on the cost of capital, an investment is going to be to have, let's say, an investment is going to have a positive NPV, or on the contrary, a negative NPV. So this is why it is important. Moreover, payoffs coming from the investment are also potentially risky. So there is, for each investment, you're going to have one return in state 1 and another return in state 2. Okay, so here, but this is just a notation and a way to simplify presentation. What we're going to do is the following. But remember, this is just to simplify things. So if I take asset 1, if it is S1, the return is going to be R1. But if it is S2, then the return is going to be negative, so a loss. And basically, it's the contrary for asset 2. So if it is state 1 minus R2, and if it is S2, R2. Okay, that's the way you can think of this. But this is maybe the simplest way to present the fact that knowing the future realization of the state of the world, you see that if you guess that the realization of the state of the world is going to be state 1, then you should rather invest in asset 1. But if you think that the realization is rather going to be state 2, then the best investment is asset 2. Okay, so in other words, these two financial assets are perfectly negatively correlated. Okay, so there is a negative correlation between these two assets. Okay. So we make the assumption that, well, it's not really NPV, is expected return or expected payoff are the same. That is to say, if I put the probability of realization, I've got for asset 1 and for asset 2 and here we make the assumption that 1 is equal to 2. So same expected returns, expected payoffs. But asset 1 is more risky than asset 2. Okay, so let me give you an example. It's quite easy, but just to make sure that you understand this. So for instance, you've got so this is asset 1 and expected payoffs are and asset 2 is $50 still. Okay, but so in which sense can we say that asset 1 is more risky than asset 2? Very easy, because the variance of asset 1 is strictly higher than the variance of asset 2. Okay, so for instance, so it is in our case it is and this is strictly higher okay, sorry, square. Of course, 1 is strictly higher than 2. Okay, is that clear? Shouldn't. Nothing. Okay. Okay. So this implies that set 1 is more risky than a set 2. And to simplify, we assume that the discount rate is normalized to 0. Okay. So I repeat, there are two agents, two states of nature. T chooses to invest either in a set 1 or in a set 2. The risk manager either can confirm choice of the trader. So in other words, the risk manager does not directly shoot the investment, but the trader has to obtain confirmation of the investment by the risk manager. Else, the risk manager can reject the choice of the trader. So what about the model? The earnings. What about earnings? So of course, if there is no investment, in case of no investment, both the trader and the risk manager just get 0. So if there is investment, actually there is a wage function, let's say, or remuneration function, both for the trader and for the risk manager. So for the trader, it is a function which depends on the return. So you've got G of the return in case of state 1 and G of R2 in case of state 2. Okay. So to make, okay, so let me detail this a little bit. So if set 1, you're going to have G of R1 and G of minus L1, but this has to be positive. So this is due to limited liability. And if a set 2, you have G of minus L2, but which is just equal to 0 due to limited liability. And you have G of R2, which is strictly positive. Okay. But moreover, this function, the function G is increasing. So this implies that G of R1 is going to be strictly higher than G of R2. Okay. So this is quite easy, I think. So what about the risk manager? Well, for the risk manager, the remuneration is now H of R1, H of minus L1, which is also equal to 0, minus C tilde. So if So set 1. So in other words, the difference between the risk manager and the trader is that the risk manager takes into account the cost of capital, which is not the case of the trader. Okay, and if set 2 age of minus L2, which is equal to 0 due to limited liability, and age of R2. And sorry, minus in both cases, minus the cost of capital. Okay? So is that clear so far? And then I'm going to talk about that. About this assumption. Okay, great. So let me now talk about this assumption. Okay, but before, okay. Okay. Age is a age into the wage or the remuneration risk manager. Okay. So we have that G of R1 over G of R2 Okay, so this is the assumption this corresponds to the assumption we are looking at. Okay. Okay. Sorry. What is the meaning of this? How could we interpret this function? So first, you can notice that this is So it is equivalent to this. Okay, so we see that this is something which is related to investing in set 1, while this is something related to investing in a set 2. Okay, so okay. So let me consider the following timing. So first there is the trader. So he or she select or set 1. And then the risk manager. So the risk manager either confirms or rejects the choice of the trader, choice of T, knowing the cost of capital, C. So there is no longer tilde on C, because when here we can, and over there it's the same but with a set 2. So trader and risk manager. But the difference, well, is that here it is with a set 1, while there it is with a set 2. But when the trader, when the risk manager confirms or rejects the choice of the trader, he or she knows the realization of the cost of capital. So this is why this is no longer C tilde, this is just C. Okay, so knowing C, so the risk manager is going to accept to confirm the investment if and only if this is lower than his or her expected return, which is, sorry, there is a mistake over there. There is a mistake over there, which is because it's going to have this with probability 1/2 or 0 with probability 1/2. So the expected payoffs for the risk manager are equals to age of R1/2. Okay. So let's say there is T equal 1, T equal 2, and realization, 3 returns. So either state 1 or state 2. So at T equal 2, the risk manager confirms T choice if and only if C is lower than over 2. Confirms, sorry. Confirm the choice by T of investing in a set 1 if and only if we have this probability we have this, sorry, this is not a probability. If we have this condition. So what is the probability now that C be lower than h of R1 over 2? Well, we know that C is distributed according to F. So distribution function is F. So this is precisely F of h of R1 over 2. Okay, so now we are close to this expression. Why? Because by choosing a set 1, the expected remuneration of T is G of R1, but with which probability? So first, it has to be confirmed. It has to be confirmed by the trader, which is going to happen with this probability. And a set 1 must, and the state of nature must be state 1, which is going to happen with probability 1 over 2. So we obtain this expression. And you see that so I repeat, by choosing the set 1, T expected gains are and what about, and by choosing a set 2, well, basically the same, but rather than considering a set 1, we consider a set 2. And having kind of a natural preference for risk, that is for a set 1, means that 1 should be greater than 2, which is you see that you can simplify by this, and you end up with the assumption we were considering. So strict, if I put this strict preference, okay. And this is precisely what we want. I mean, a natural preference for excessive risk taking. So there are questions. Okay, so RM remuneration has to be thought as not only, well, this is for, okay, so for RM remuneration, this is one possibility to explain why RM is not as much interested in the result as the trader is. So the way they do that is by considering that the risk manager remuneration also depends on the cost of capital. Yeah. Yes, in case of loss, RM is protected by the limited liability, but RM must pay for the cost of capital. So in other words, the objective function of RM is closer to the objective function of the board of direction, to the bank's CEO. So taking payoffs, but also cost of capital. So you pay the capital, but you don't have to support from the extra losses which could be associated to an investment. Yeah, this is precisely so about the level of the two bonuses. You see that so this is precisely what is written over there. That you look at this. So you see that the difference between the two bonuses should be high enough. Okay. So the difference between the two bonuses should be, so this is bonus 1. So bonus 1. This is bonus, well, it could be interpreted as bonus 2. Okay, and the difference between the two should be high enough. Difference between the two should be high enough. But by the way, when we talk about difference, either you make the difference between the two, and this is not the way we look at the difference, or you take the ratio between the two. And this is the way we find the condition. Okay, we are considering the second way. Okay. No questions? Nothing? Don't be shy. Okay, I see your point. In the two cases, it is actually halved. Let me show you. Look. This is written over there and over there. So I repeat. So this is bonus. If bonus 1, if what? If RM confirms and if state 1 occurs. So the probability of confirmation is F of R, not R, H, R1 over 2. And the probability that state 1 occurs is 1 over 2. So you're right. It is over 2 times that's the expression. And this is for a set 1. But we compare this to the same, but for a set 2. So for a set 2, it is J of R2 times F of H of R2 over 2 times 1 over 2. So if So bonus 2 if Rm confirms and if state 2 occurs. Okay, so this is J of R2 now over 2 times F of. Now we've got this expression, but we want 1 to be greater than 2. So you see that you can simplify. You can simplify. There is a mistake. You can simplify. And if you simplify, you obtain this expression, okay, by simplifying. Okay, another question? Okay, great. So if you don't have other questions, let me go ahead. Okay, so that is where we were. So that's the timing. But there is one slight difference between what I presented to you just before. So previously, the timing was that one. Okay. So this is with no signal, but actually the work of a trader is to look at markets, financial markets, and try to understand which asset is going to be more profitable in the future. So you remember I told you there is no particular information. So first the trader chooses an investment. The risk manager either confirms or reject the investment, and at T3 payoffs are realized. But here we consider that actually before the trader takes his or her decision, there is a signal. So let's say at what we call now T1, there is a signal about not future payoff, but about future state of nature. So this is now T2, this is T3, and this is T4. So what is going to be modified is that after receiving the signal on the future state of nature, the probability of occurrence of each state of nature is modified. So this is the a priori distribution. So a priori probability, the two a priori probabilities of realization of each of the two states of nature. But now it is modified. So let's say if, so the signal is called sigma. Sigma is a signal, right? So sigma is a signal. So sigma could be either 1 or sigma is 2. So if sigma is 1, it means that it is rather state 1 which is going to occur. And if sigma is equal to 2, it is rather state 2 which is going to occur. Okay. So with this, we have a conditional probability based conditional on what? Based on the signal, the received signal. Okay. And we call alpha, it is probability of having state 1 if the signal is equal to 1. And so we're going to have 1 minus alpha, which would be probability of state 2 if sigma is equal to 1. So either we've got this, so this is associated to sigma 1, to sigma equals to 1, or sigma is equal to 2. In that case, we have alpha, still alpha, but which is probability of state 2 knowing sigma is equal to 2. And 1 minus alpha now is the probability of having state 1 knowing that sigma is equal to 2. Okay, these are the two possibilities. But remember that this is something important, because there is one new aspect, which is the nature of the signal. Okay, so taking into account the signal, the public signal, what, let's say, would be, and by the way, alpha is greater than 1/2. What would be the natural choice expected from T? Remember that alpha greater than 1/2. What do you think? Who has an idea about that? So I repeat, sigma is an indication, a signal about the future state of nature which is going to occurs. So in other words, if sigma is equal to 1, people think that state 1 is more probable than state 2. But if sigma is equal to 2, people think that state 2 is more probable than state 1. And you know that asset 1 is going to yield payoffs only if state 1 occurs, whereas asset 2 is going to yield payoffs only if state 2 occurs. So what would be the natural choice of the trader? What do you think? Nothing. Come on. So following alpha equal 1, yeah. Following alpha equal 1, he should rather choose that 1. But this is not a problem. This is not a problem because even without more information, is corresponded to the choice of T. So this is not a problem. But following alpha equal 2, he would rather choose the set 2. Okay. But it is not so sure. Why? Because there is a trade-off. For T. You see that on the one hand, by choosing a set 2, the trader knows that he's going to obtain a return with a higher probability. But on the other hand, by selecting a set 2, the return the trader is going to obtain by selecting a set 2, the return the trader is going to obtain is lower than the return, the bonus associated with asset 1 if state 1 occurs. So there is a clear trade-off for the trader, right? Do you want to make break as usual? Are you interested? Okay. So let us make 20-25 minutes break, right? And we will finish with this. Okay? You agree? Okay, cool. So see you in 20-25 minutes. See you. Okay, so I think it's time to restart the lecture. Okay, so there we are. There we are. So this is something that actually we were talking about. There are two types of equilibrium. Two types. One which is called a reactive equilibrium. So the reactive equilibrium is making the investment in some extent recommended by the signal. Okay, so selecting a set 1 if sigma is equal to 1, or selecting a set 2 if sigma is equal to 2. So this is a reactive equilibrium. But there is, let's say, a wrong equilibrium in which the trader always selects a set 1, whatever the signal. So basically, this equilibrium is excessive risk-taking. This is excessive risk-taking. Okay, so you see that there is one new condition, that one. So this is the new condition. So this new condition is a little bit different from the one we obtained previously. But it looks like a little bit like the previous one. What is different now is the probability which are taken into account. Okay, so let me give you more details about that. So the reactive equilibrium. So if a set 2 is selected by T, so in case of success, the trader is going to receive this bonus 2. This is going to happen with probability now alpha. This is no longer 1/2, but what is the probability that Rm confirms? Well, Rm is going to confirm if and only if alpha h of R2 is greater than C. And the probability that for C to be lower than alpha h R2 is f of alpha h R2. So there you have f of alpha h R2. Okay, and this has to be higher than the expected gain. So let's say that the signal, and this is important. The received signal, sigma, is saying rather state 2. So if set 1 is selected by t, while always with, so this is of course with alpha equals 2. So in that case, in case of success, the return is g of R1. But this is going to happen with probability 1 minus alpha. And Rm must confirm the investment. If and only if 1 minus alpha h of R1 is greater than C. And at t equal 2, when the trader takes his or her decision, the probability that C be lower than 1 minus alpha h of R1 is f of 1 minus alpha h of R1. So there you've got this. Okay. So if this inequality is satisfied, if this is satisfied, then there is the reactive equilibrium exists. But if not, so if the inequality goes in that direction, we would have the non-reactive equilibrium. So excessive risk taking. Okay, and why could it be the case? Because alpha is greater than 1 minus alpha, that's right. But g of R1 is greater than g of R2. And most of the time, most of the time we've got g prime positive, but g second also positive. So something which is increasing and convex. And you see that in that case, the difference, so here you have results, and there you have payment of bonuses, remuneration. So actually, because of the convexity of repayments, the difference between the two can be quite important due to increasing and convex remuneration function. The difference can be important, can be large. And if the difference is large, we're going to have the non-reactive equilibrium, that one. Okay. You understand that? So in other words, the probability matters. Of course, if by selecting the wrong investment, the probability of obtaining a payment is close to zero, well, it's not possible. But the difference in terms of payment, whether it is the asset 1 or asset 2, which is chosen, implies a difference. Okay. Okay. So proposition 1, the possibility of having reactive equilibrium decreases when T's salary increases further with large payoff, growth and convexity of T's compensation function. That is, when G of R1 minus G of R2 increases, or G of R1 divided by G of R2 increases. Okay. This is exactly what we saw. The same for the risk manager. Why? Because if I come back to so in this slide, you see that what also is important is what is written over there. Okay, and we know that age of R2 is lower than age of R1. So if the difference is important, can make this probability greater than actually the other. So alpha strictly higher than 1 minus alpha, but if age of R1 is large enough compared to age of R2, we can have f of 1 minus alpha is age of R1 close or even greater than f of alpha age of R2. Okay. Okay. So this is another possibility, but I don't want to go into the details because I don't have the materials to do that. So what about variable cost of capital? So the idea is to say that Sorry, this is quite far. It is over there. So actually, conditional on the signal, choosing the wrong investment is more costly than choosing the right investment. So this is going to modify our condition, and of course, this is going to be helpful in obtaining the reactive equilibrium. Okay, so this is what I'm going to develop now. So consider the following. So if, sorry. So now we consider that the cost of capital depends on the chosen project. So if sigma is equal to 1, or set 1 is chosen, so the cost of capital would be C. But if a set 2 is chosen, the cost of capital would be C plus lambda. Moreover, in the other case, if sigma is equal to 2, the set 2 is chosen, the cost of capital would be C tilde. But if this is a set 1, which is chosen, then the cost of capital increases. It would be C tilde plus lambda. So in other words, following a signal, following the signal, the public signal, following the public signal, if the chosen asset is not the one associated to the signal, then the cost of capital increases. C tilde plus lambda versus just C tilde. Okay. Okay, so now consider that the signal, consider that the received signal is sigma equal to. So the appropriate investment is a set 2. So expected gains of T if a set 2 is selected. Well, this is G of R2 with probability alpha times the probability that the trader accepts a set 2. So probability, sorry. So RM confirms set 2 investment if and only if alpha H of R2 is greater than C. And the probability that RM confirms is probability that C be lower than alpha H R2, which is F of alpha H R2. So this is times F of alpha H R2, exactly as before, the same as before. This doesn't change. This doesn't change. But what now? The what if T selects the set 1? So in that case, the expected gains of T would be G of R1 times 1 minus alpha, probability of occurrence, times the probability that the risk manager accept confirms the investment in a set 1. So RM confirms set 1 investment if and only if 1 minus alpha H of R1, so this is the expected gains, of RM is greater than C plus lambda. Now there is plus lambda. Plus lambda. And the probability that RM confirms is, so this is basically equivalent to C being lower than 1 minus alpha H of R1 minus lambda. So there we have And of course, so notice that this is lower than 1 minus alpha h of R1, and therefore f of 1 minus alpha, this is lower than f of h of R1. So now the condition is that one should be greater than 2, 1 greater than 2. So it is so this is the condition we are interested in. And this condition is more easily satisfied than why? Because actually, f of this is lower than this. Okay. So this makes actually the reactive equilibrium most easily obtained. So in other words, if the cost of capital increases when the wrong investment is made, it makes the reactive equilibrium most easy to obtain. Okay, it is easier to obtain the reactive equilibrium in such a case. Questions? Let me know. Stillness is not a good sign when you are teaching. You should ask questions and pay for it. So you see that one way to make the reactive equilibrium more possible is to have kind of a flat wage for the risk manager. Having a flat wage for RM makes the reactive equilibrium more easier to obtain. You see that if so you see that if you have a flat with a flat wage for RM, you would have H. This would eliminate the problem actually, except in one case, and this is what we are going to see now. This is the case of bribing. It's not good, huh? It's never good to bribe. Okay, so if there is variable cost of capital, depending on the available information, well, it makes the reactive equilibrium more probable. And for alpha high enough, the reactive equilibrium always exists. Bribing, this is not good. Never good. Collision with the trading floor. And this is basically something that we saw during the last subprime mortgage crisis, because bonuses were so high that it was quite easy for a trader to bribe a risk manager. Okay, so now the problem is that trader can collude with RM in the sense that the trader can bribe RM such that RM always confirm the selection of a set 1. Okay, and let W be the bribe. W is the amount of bribe. Okay, so of course the result is easy to understand. The result is that in a case in which the reactive equilibrium exists without bribe, only the non-reactive equilibrium can exist if there is a bribe. Okay. So it makes easier the possibility for the trader to convince risk manager to confirm asset one. Okay. So this is basically what is written over there. So the reactive equilibrium would exist without bribing possibility, but the equilibrium with bribing is non-reactive. Okay, is only non-reactive. Yes, let me convince you about that. And then I think, okay. Collision with the trading floor So in that case, we talk about a rogue trader. So W is the amount of bribe. So you see that following those public signal, consider that the public signal is 2. So the appropriate, once again, the appropriate investment is asset 2. So in that sense, in that case, the expected payment or gains of T if asset 2 are alpha J of R2 times F of alpha H of R2. What if asset 1 is chosen? So we still have 1 minus alpha J of R1 times probability that Rm confirms, knowing sigma equals 2 and the bribe. Aha, I see. I see the point. Doc. Ah, here we go. Okay. So I repeat. So collision with the trading floor. So in that case, we talk about a rogue trader. There is one famous example in France, which is called Jérôme Kerviel. Jérôme Kerviel is an example of a rogue trader. A huge problem with Société Générale. So W is the amount of bribe. So T gives W to Rm if sigma is equal to 2, T selects a set 1, and Rm confirms a set 1. In that case, the risk manager receives the bribe. So if sigma, the public signal, is 2, we know that the appropriate investment is a set 2. And this would be the expected gains of the trader if the realized investment is a set 2. Exactly as before. Exactly as before. What if a set 1 is chosen? So in that case, probability of success is 1 minus alpha. The gain is J of R1 minus the bribe. But what is the probability that the risk manager confirms? Well, actually, the risk manager is going to confirm if and only if 1 minus alpha H of R2 plus the bribe is higher than C. And the probability that C be lower than 1 minus alpha H of R2 plus alpha plus omega, of course, increases with W or omega, whatever you can call it. So now it is 1 minus alpha times F of and you see that this is going to be increasing. This is, of course, increasing with W. Okay, so by paying the risk manager, if the risk manager confirms a set 1, the trader, of course, increases the probability that for a set 1 to be confirmed by the risk manager, even if it is not the appropriate investment. Okay. Okay. Do you have questions so far? No, really. What do you mean by if f the x is equal to x? Where is it written? In the slide, maybe. Okay, I see. Okay, good question. Yeah, I see. Well, this is consider that the random variable is uniformly distributed over 0, 1, then we would have distribution function f of c, which would be just equal to c. This is an example. And this is an example in which it works. Okay. Another question? With pleasure. Another question? So if there is no other question, maybe we can look at the, there is one exercise which is missing. And we can try to go through the exercise. Okay? So let's do that. No. Yes, this one. This one. Okay, so now the question is not only to finance a single project, but to finance several projects. Okay, so this is basically still a problem of moral hazard, but not with a single project to be financed, but with several projects. So an entrepreneur wants to undertake, let's say, 2 projects. The 2 projects are identical, taken on a standalone basis. Each project involves a fixed investment cost, capital I, and yields profit R in case of success, and 0 in case of failure. The probability of success of each project depends on the behavior of the entrepreneur on each project. If he or she behaves well, the probability of success is equal to PH, while it is equal to PL if he or she shirks, with PH greater than PL, exactly as usual. Moreover, if the entrepreneur prefers to shirk, he or she obtains a non-transferable private benefit, capital B. The entrepreneur can choose to behave well on both projects, to behave well on only one project, and to shirk on the other project, or to shirk on the 2 projects. If the entrepreneur shirks on one project but behaves well on the other project, his private benefit is equal to capital B. However, if he shirks on both projects, his private benefit is equal to 2B, B for each project. And finally, we assume that the entrepreneur has wealth, which is retained earnings, once again, which is equal to 2A, capital A. Lenders are competitive, everybody is risk neutral, and protected by limited liability, and do not discount the future, just to simplify. In the following, we will denote RK what the entrepreneur gets when K belongs to 0, 1, or 2. So either 0 project succeeds, or only one project succeeds, or the two projects succeed. You will consider that R0 equal R1 equal 0. So in other case, the entrepreneur obtain only something in the case in which the two projects succeeds. If 0 project succeeds, or only one project succeeds, the return to the entrepreneur is just 0. And this is to simplify the analysis. Okay, so we're gonna start with no, okay. We're gonna do that. Suppose first that the two projects are uncorrelated. Show that the entrepreneur can obtain financing provided that this condition is now satisfied. Okay, so now rather than only one incentive compatibility constraint, there are two incentive compatibility constraints for the entrepreneur. One which said that so expected gains of the entrepreneur if working in the two projects, this should be higher than the expected gains of the entrepreneur if shirking in the two projects okay. So expected gains of the entrepreneur working in the two projects. Well, this is what is the probability that project 1 and project 2 succeed at the same time. You see there is an end, so it is pH times pH, so it is pH square R2. And this has to be greater than the expected gains of the entrepreneur if shirking in the two projects. In that case, the probability of success is PL for each project, and you want the two to succeed together. And you obtain 2B. So this gives you that R2 must be greater than 2B over what? Over pH square minus PL square. And this is 2B over pH plus PL times pH minus PL. And this is basically condition 1. The other condition is that So the entrepreneur must prefer working on the two projects rather than only in one of the two projects. So in that case, if working on the two projects, well, expected gains are the same. But so if working on one project and shirking on the other project, you see that you're going to have pH 1 minus pH, success, and PL 1 minus PL, success. So since you want the two success together, the probability is pH times PL. And you obtain only one private benefit, not two private benefits, because the entrepreneur is just working on one project, but shirking on the other one. Okay, so actually you obtain two conditions. So we obtain condition 1 and condition 2. But actually, it is quite easy to see that. Okay, so if I take this one, I've got that R2 times pH2 minus pH PL should be greater than B, which amounts that R2 being greater than B over pH minus PL. And actually, we want to show that, the question is it lower than 2B over pH minus P plus PL? And this is the case. So we've got this. So you can divide that by B. And the question is, 2 pH, is that greater than pH plus PL? The answer is yes, because pH is greater than PL. Okay, so actually only this condition, this is the binding condition. And finally, what you have to find is that is to write down now the participation constraint of So participation constraint of the lenders. And so you see that for the lenders, they're going to obtain 0 due to limited liability. They're going to obtain, if only one project succeeds, they obtain R minus R1, but R1, this is equal to 0. So they obtain 0 R, and in that case 2R minus R2, so minus 2B over PH plus PL times PH minus PL. Okay, so the expected gains actually for the lenders is just what is written here, because this is going to happen with probability pH square. This is going to happen with probability, so this is PL square. And what about this? Well, it is pH minus 1 minus pH times 1 minus pH plus 1 minus pH times pH. So it is 2 pH 1 minus pH. So this is why over there you find 2, because there are two ways, and this should be greater than the required initial investment, which is no longer capital I minus capital A, but it is twice this amount, because there are two projects actually which should be financed. And if you make simple computations, well, you end up with what we were interested in. Questions, it's time. Sure, I will. Okay. So here, so in this question, projects are uncorrelated. Okay, let's say independent, one from the other. So you can write this like, this is for project 1, which is either success or failure with probability pH 1 minus pH, right? And then there is project 2, is a success or failure with same probability. And here it's the same. So if you want success, well, there is only one way. Success. So only one way. And the associated probability is pH times pH square. If you want failure, same. Only one way. And the probability is PL square. But if you want one success and one failure, well, there are two ways now. Two ways. Either success and failure, or failure and then success. So the probability is pH times, pH times 1 minus pH plus 1 minus pH times pH. And this is 2 pH 1 minus pH. And about the returns, well, there is 0 because failure. So due to limited liability, and R1 equals 0. This is in the exercise. So in that case, for the lenders, they will get R plus 0. Success of one project, failure of the other project. In case of two successes, you've got 2R minus R2. And this is, and R2 is the expression we found. R2 is 2, yeah. So it is okay. And so the participation constraint of the lenders is pH square times 2R. Sorry, it's not R2, it's just R. Minus 2B plus 2pH 1 minus PL should be greater R. And this should be greater than 2 the required investment. Is that clear? Okay, so I think it's time to stop. So it was a pleasure for me to teach this all of these lectures. And do not forget that there is a last Q&A session. So a Q&A session on the 26th of May. We'll see you then. Take care of you, work well, and see you on the 26th of May, right? Goodbye, au revoir, see you later. Thank you all.
You are currently the only person in this conference.